Hello everyone. So this is a video and I'm going to talk in this video about what's called Bohr models. And so this lecture is supposed to follow after the Unit 4 test. So what I'm talking about in this video was not on the Unit 4 test. So if you're like, oh my God, this doesn't look familiar, oh no, like that's okay because I didn't want to, even though this was part of chapter 4, and I did put some stuff regarding the Bohr models into the chapter 4 packet I handed out to you and supplied to you. It was not part of the test. Okay, I didn't want to add that last piece to the test, just for more stuff for you to study and make sure you needed to go over. So I wanted to do it like a separate mini unit after the test, which is what this is, just kind of explaining what a Bohr model is and how to draw one. So this should be, I hope, a relatively short video today, just kind of explaining what Bohr did, because we already talked about Bohr a little bit in our History of Atomic Theory foldable and our atomic structure history notes. But now we need to explain how to draw a Bohr model. And so that was actually your last I can statement, in your chapter 4 packet, but we just didn't do it because, like I said, I just didn't want to test you guys on that in the Unit 4 test. But this is the I can statement. It was to decipher and create Bohr models, orbital notation, and Lewis dot diagrams for any main body elements found on the periodic table. So I'm going to teach you how to do that today. It's not too difficult, but I am going to give you some context in the lecture so that you guys won't just say, okay, I know how to draw this thing, but what is this thing? So that's why I'm going to give you a little bit of context when I'm explaining this. So I supplied to you on Google Classroom the PDF of the student copy of the notes, so you can fill those in, and then your assignment will be to fill in those blanks and then complete the pages of this packet that help you go over what we learn. Okay, so I'm going to get right into this. Come on. There we go. Okay, so we're talking about that electrons and atoms. We already kind of talked about them in terms of, how many electrons does an atom have? And in a neutral atom, we said that the number of electrons is equal to the number of protons, okay? So that's still what we're going to use today when we're making these Bohr models. But just to give you a little context, I'm going to go over some things really quick. So electrons are organized in what we call energy levels, and so electrons aren't, just thrown around the nucleus. They're kind of organized into levels, and in a real atom, it doesn't actually look like this, where it's all neat and perfect and like a circle here and then a circle here. It doesn't look actually like that, but it's a good way of looking at it for learning how to draw where the electrons are in the atom. So this is just kind of how we're going to explain it. And we're going to say that we already learned about Niels Bohr and how he proposed the quantum model of the hydrogen atom. And basically what Bohr did was he said, okay, I think that electrons are organized in energy levels. So basically this lowest energy level with the notation of 1 has the lowest energy. And then if you go up one more, it has a little more energy. This N2, labeled N2, has a little more energy than our N1, and then so on. It gets more energy as you go outwards. And so that's kind of what Bohr did in more detail. And so to summarize that, the ground state is the lowest energy state. So this would be your ground state. This N equals 1 is the lowest you can go. It's the closest to the nucleus, okay? And so that would be your ground state. Your excited state is so atoms can accept photons, which I don't know if you guys know what a photon is, but a photon is just light. Photon is a fancy name for a packet of light. Literally, photon means packet of light. And we know light has energy. That's how photosynthesis works. So if light has energy and it enters an atom, that energy from that light will excite the electrons in it. It'll get the electrons all nuts. So when the electrons get all crazy and nuts, they jump up to a higher energy level. So, for example, if we have our, there we go. If we have our electron on this energy level, which we know is the ground state because it's the lowest, and it gets a photon of light, it gets energy from the light, it will jump up to the second or third energy level because it's excited because of the light, because the light gives the electrons energy to jump up to a higher energy level. And that's what we call the excited state, okay? I already kind of mentioned this, but the energy of the energy level increases as you go away from the nucleus. So another way you can say that is the smaller the electron's orbit, so, the smaller orbit is going to be closer to the nucleus, the lower the electron's energy level, okay? And then the bigger the electron's orbit, aka the farther away it is from the nucleus, the higher the electron's energy is going to be, okay? So that's just some background information. So when we talk about orbits, so these little circles around the nucleus, what Bohr did for math reasons that I'm not going to talk about, because half the time I don't even understand them, but Bohr assigned quantum numbers to each orbit, which I kind of already mentioned. So the closest one to the nucleus is going to be n equals 1, and n just means like what number orbit is this. And so the one closest to the nucleus is 1. The next one, one step away from the nucleus, is 2, and then 3, and then so on, okay? And so when we talk about hydrogen, we know that hydrogen's atomic number is 1, okay? That's how many protons it has in a neutral atom. Hydrogen will also have 1 electron, okay? Because remember, electrons have to equal protons in a neutral atom. So electrons in hydrogen's neutral state, there's only 1, and it will usually sit on n equals 1. And it will usually sit on the first energy level, the lowest. And that's its ground state. Then the electron can get excited. Remember, I talked about that photon of light, which is just energy being transferred to the atom from light, and that will move it to n equals 2, and that's the excited state for hydrogen. Okay, I hope this makes sense. It's kind of an abstract topic, which is kind of why I didn't want to test you guys on it. I just wanted to do it as kind of a mini unit so you guys saw it and got exposed to it, but weren't, required to know every detail about it. So we can move on. But this slide is just telling you about how you have these orbits around the nucleus, and the closer it is to the nucleus, the lower the energy, and that is the ground state, and it's labeled 1. Okay, and then the farther out you go, it's labeled 1. You go out further, 2, 3, 4, and so on. And I put this up here, that orbits are basically like how when you learned about the solar system, you learned how the sun is. On the outside, you have the planets, right, orbiting the sun. So same thing in atoms, the proton in hydrogen, which is its nucleus. So the nucleus in the center is basically like the sun in our solar system. And then the orbits with the electrons going around the nucleus is like the planets going around the sun. So I liked that analogy, and so I hope that helps you kind of visualize the movement of these electrons around the nucleus. It's kind of like the orbiting of our planets in our solar system. So this is going to be kind of a confusing slide, but I added a lot of pictures here to help explain it. So photons, I told you, are packets of light. It's just packets, literally packets of light is the definition. And they can either go into an atom, like I explained, or they can go out. So when you're going into an atom, so we have our electron on our ground state because it's on 1, n equals 1 right here, right? And then we see the photon of light going in with its energy. It hits the electron, gives the electron energy. So when the electron gets energy, I told you guys that will jump to a higher, it'll jump to a higher energy state or orbit. So it'll jump to a higher orbit. Okay. And when it does that, it's called the excited state. Okay. So that's when photons are entering the atom. And so, like I said, when photons enter the atom, they can excite an electron and move it to a higher energy level called the excited state. And then what I didn't mention yet, but I'm going to do now, is that electrons can also move down energy levels. So it can get excited, but it can also, get down and go back to the ground state or the lowest energy level. Okay. And so, say we have our atom of hydrogen, okay, with its one electron in its neutral atom. And we have hydrogen's electron all excited out here. So I'm in this graphic up here now. So we have hydrogen's one electron out here, all excited and everything. It already got its energy. But it's like, okay, I'm done being excited. When it's going to move down to its ground state again, so it's going to move back down an energy level, it's going to release energy instead of taking it in, okay? And so when it releases energy, it releases it in the form of light. And so when it goes down from 2 to 1, it's going to release a certain photon of light. And so that's what it means when I say the electron moves back to the ground state, so back to the lowest energy level. It releases a photon of light. And so this you don't really need to know. I just kind of put it in here for context. But say you have, instead of moving from 2 to 1, maybe you're moving from 3 to 1. That amount of energy is going to be different than moving 2 to 1. So 2 to 1, the amount of energy released is going to be different from the amount of energy released going from 3 to 1, okay? And so the amount of energy a photon has determines what color it is. So basically, like, red is low energy and purple is high. So if we're jumping from 3 to 1, that would probably be more like a higher energy, like purple or blue. And then if we're jumping from 2 to 1, that'll probably be a lazier, less energy photon of light, which is probably like an orange or a red. Okay, like I said, you don't need to know that, but it's just kind of, it's interesting to know where light comes from. And so that's why I put this here behind my head. So this is just an example. It might look kind of confusing, but so depending on how excited your electron is and where it jumps to, so this is kind of what I talked about. So if you're on the second energy level and you jump back down to the first, it's going to release this amount of light. Okay, this energy of light. But what if you're on like the fifth energy level, like the fifth shell, orbit, whatever? You can jump back down to the ground state and release a completely different amount of energy, aka a different color of light. Okay, so that's just what this is showing you. So don't let this thing behind my head scare you. That's just what it's showing you, that like depending on where you're jumping from, different light will be released. Okay, but the whole point of this slide is just to tell you that, when you are getting excited, photons are entering the atom. When you're going down from being excited, so when you're going back to the ground state, that's when your energy is released, okay? That's when energy exits the atom, okay? So we learned about Bohr, kind of what he discovered, but he did have some issues, which, I mean, not everything is that easy in science, so we can't just say, oh, this is exactly how an atom looks, and this is exactly how electrons move, because of course science can never be that easy. We're not going to get into the details about how it actually works and how it actually looks, because even though Bohr's explanation of the hydrogen atom and energy shells only works for hydrogen, it doesn't work for any other element, and electrons don't really move around in just a perfect circle. It probably moves around like a wave. But despite all those things that are wrong with Bohr's theories and model, it did have a lot of good things about it. So his ideas led to a lot of other groundbreaking discoveries. So because he set the fundamental groundwork down to say, okay, yeah, I think electrons have energy levels. That's true. It's just the way they're oriented was not right in his model. But because he just hypothesized that I think energy or electrons are organized in energy levels, other people went on to think about, oh yeah, maybe it does, maybe he's right. And they went on to make more discoveries about how electrons actually move in atoms. And so another good thing about Bohr's model is even though it's not completely correct, it's a really good way to think about how electrons and atoms move, and it's a good way to honestly teach about how electrons are arranged in atoms. So those are Bohr's good points. And also, Bohr also has a good point of having the same birthday as me. So if you got that question right on the test, you'll get a point of extra credit. I always mention that whenever I teach about Bohr. I'm like, yeah, he's my birthday buddy Bohr. Him and I are both Libras, so I don't know what that tells you, but finally, I'm going to kind of talk about quantum numbers, and don't get scared about the word quantum number. It's just like these, the 1, 2, 3, 4 that I already told you about. So you already learned this like in an earlier slide, but the quantum numbers are just telling you, remember what energy that has. And so another thing that quantum numbers can help us do is write our actual Bohr model. So draw our actual Bohr model. And so when we draw our Bohr model, we keep in mind that the first energy level can only hold 2 electrons. And I'll explain what that means when we get to the actual practice. The second energy level can only hold 8 electrons. The third energy level can hold up to 18, and the fourth can hold up to 32. So I'm going to kind of I'm definitely going to do an example, but I'm going to kind of explain what that means, like can only hold 2 or can only hold 8 as I do it, okay? So if we go to the next slide, this is where we're actually going to do our practice, okay? So we have 2 practices, so how to draw a Bohr model. First, we're going to draw a boron, and then we're going to draw a phosphorus, okay? So when we draw boron, the first step to drawing a Bohr model is to just draw the nucleus, just like we have been doing, okay? And so boron, we need to look up a periodic table. So I pulled up the periodic table that I supplied to you guys a couple weeks ago. I can repost it on the agenda. Well, I will repost it on the agenda after thinking about it. But so we need to know boron's atomic number because we're assuming that this atom of boron is neutral. And so we're going to look at boron and see its atomic number is 5. Okay, so here we see 5. And so we know it has 5 protons. And since this is neutral, we know it also has 5 electrons. So we're going to use that information to draw our Bohr model. So I'm going to put in parentheses right here 5 electrons, just so I know how many I need to draw. But remember, first things first, I'm going to draw the nucleus. I'm just going to draw a little dot here. Some people you might see do this, where they draw like a circle and put like 5p and like 6n, depending on like the isotope, but like I'm not going to do that. Oops. Come on, go away. Whatever. Pretend that's not there. So I'm just going to draw like this for simplicity. So we have our nucleus, right? And we know that's going to be our center. Just like these, these models down here, we're going to draw our circles around the nucleus. Okay? So we're going to go ahead and draw the first circle. And I'm just going to draw 2 to start with and see where we get from there. My circles are not good. I'm sorry. So we know we need 5 electrons. And I told you this information down here. So I told you that the first energy level can only hold 2 electrons. The second can hold up to 8. The third can hold 18. and the fourth can hold up to 32. So that information is going to come in handy right now, because when I'm drawing these, you might be like, well, I don't know where to put the dots that represent the electrons. Like, I don't know what to do with those. This right here tells you what to do with them. Okay, so this down here tells you like where to put them. So we want to fill up the bottom ones first and then work our way out. So we're going to go ahead and put 2 electrons out here. So 1, 2. Okay, so there's 2 out of our 5 electrons. And so this is full now, because if you look down here, this can only hold 2 electrons. So it's full. It can't hold anymore. But we know the next one can hold up to 8. So we're going to go work on the next one now. And we know we have 3 more because we have 5 total, and we already have 2 down. So I'm going to put 3 more out here and go 1, 2, 3. And there is our 5 electrons. So that's the Bohr model for boron. Okay? Next, I wanted to do a harder example. So next we have phosphorus. So I'm going to go ahead and draw my nucleus again. And I'm going to kind of demonstrate here. Oh my gosh. No, stop it. I'm going to kind of demonstrate here that you can draw this a variety of ways. So you can draw your nucleus as a big circle if you want to. I fill mine in sometimes, so you can draw it either way. So I'm going to continue by drawing a few orbitals around my nucleus. Oh my god, that was really bad. Sorry. It's hard to draw on the computer sometimes. And then, since we don't know phosphorus's atomic number right offhand, we don't know how many protons and electrons it has, we're going to go back to the periodic table and take a look. So here we see, let's find phosphorus. Oh, okay, so phosphorus is right here. So we see that phosphorus's atomic number is 15. That means it has 15 protons. And because we're assuming this is neutral, it also has 15 electrons. So we're going to put 15 electrons on our circles. So we can go back here. And I'm going to write in parentheses again how many electrons we're working with. So 15 electrons. Okay. So again, we have to follow the same rules. The first one can only hold 2 electrons. So let's go ahead and put 2. Remember, we start with the lowest energy levels and work our way out, okay? So I'm going to put 2 out here. See, I'm drawing it differently than I did up there. So whatever ways you're comfortable with, do it, okay? It's fine. So here are my first 2 electrons. Now I have 13 more, okay? Now is when we have to take into consideration the next one can only hold 8, okay? So let's go ahead and put our 8 around here. So we have 2 so far. So we have our first 2. Now we're going to go ahead and draw the rest of them. So 2, where am I? There we go. 2, 3, 4, 5, 6, 7, 8 total electrons. 9, 10. Okay, so now we have 8 on our second orbit, okay, and we know that it can only hold 8, so that is now full. We cannot put any more electrons on that one. But I was counting the total number of electrons as I did it, and we only have 10, so we still need to put 5 more out there. But we can look down here and see that this, where am I? Oh my gosh. This third one can hold up to 18 electrons, okay? So I'm going to go ahead and draw that third orbital out here. That's a little bit better, a circle. And I'm going to draw my last 3, okay? So that, my last 5. So we already have 10, 11, 12, 13, 14, 15. Okay, so now let's count and make sure we have 15 total electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we're good. Okay, so what you need to keep in mind when drawing these Bohr models is just these rules right here. So the fact that the first orbital closest to the nucleus can only hold 2 electrons. The second orbital The next closest to the nucleus, like one step out, can only hold 8, and then the third one can hold up to 18. And if we need to, which I don't know if you'll need to, but the fourth one can hold 32. Okay, so this one can hold 2. That's why I only put 2 on there. This one can hold 8, which is why I put 8 on there, but we still have some left over, so I had to do that third one. And we didn't get to 18 on this third one, but that's okay. We just started filling it, okay? So that's how to draw a Bohr model. I think it's pretty straightforward. If you do have questions about it, please let me know, because after taking notes from this video, which you're gonna turn in to the assignment called Bohr model video notes, or picture of Bohr model video notes, after this, you're gonna do this assignment, which I'm gonna show you really quick. So you're going to do all the way down. So you'll flip to the pretty much back of your packet, and then you'll do in a separate assignment these 2 pages. You don't have to fill in this because I did a separate notes than you did here. But I do want you to do these Bohr models, okay? So you don't need to do this, and you don't need to answer these questions. Come on, where are we going? You don't need to answer these questions, okay? So you don't need to do this, and you don't need to do this. For this, it says Lewis dot diagrams. Just do the Bohr models for those, okay? So just do the Bohr models for Lewis dot diagrams. I didn't want to teach you Lewis dot diagrams because it's just another thing I don't want to add to your plate at the end of the year. So just do more. So here, oh wait, never mind. These are the same elements. So JK, just totally skip this page in its entirety, okay? So do these blocks for your Bohr models right here. Skip this page entirely, and then do this practice page right here, okay? So this one right here, and it tells you how many you can put in each. It has the amount of electrons that can fit in each orbital, which is helpful. So just do all of these for your practice. So this page, and then if we scroll back up here, this block right here. And that will be called something like picture of Bohr practice or something like that, okay? So that's how you do Bohr models, and that's how you will do your assignment, okay? If you have any questions or this is unclear, please let me know because I won't know unless you tell me, all right?